In my wallet, each and every day, I carry this mechanical pencil, the Oto Mini Moto, and at a staggering 3.6 inches, I felt like it was time for something bigger. Mechanical pencils are one of the most affordable ways to see real craftsmanship on a finished product. They come in different sizes, shapes, colors, use cases, and the way they're constructed can be different as well. It's hard to explain, but as an engineer, it's something I think about a lot. I've always wanted to have my own mechanical pencil brand, but I wanted to make more than just an enclosure around the P207 mechanism. With the parts on a standard pencil being as small as they are, and with me not owning my own injection molding machine, I decided to go big. This way, I was able to make my own approach with my own materials within my own apartment. I wanted to go big and started with the first question: how big do I want to go? Limited by the size of my A1, I wanted to make sure I could print the tip in one piece, so it'd have to be about 10 inches long at max. I sat down in my favorite engineering software and calculated how much I could scale up the pencil to make the tip fit. Scaling up the lead from 0.7 millimeters to about 8 got the pencil to around my height, which was perfect. Naturally, I did the logical thing and started ordering materials with barely an idea in mind. I bought charcoal sticks, seeing that I could get a variety pack between 7 and 9 millimeters to try out tolerancing, but when I got them, I realized they wouldn't work. The tolerancing of a collection of burnt pieces of wood was shockingly terrible. So I caved and bought graphite rods from every engineer's favorite website. I then actually sat down to design, and it turns out it may be better to do that before buying parts online. I took apart a P207 and learned how it all came together, defining names for each part, only to learn later that there's actually defined names for all the components, which is perfect for confusing a larger audience. So if I call a dispenser a collet or a dispenser ring a collar, adapt. I started with how I was going to advance the lead. If I could fit that entire mechanism in just the tip, then the rest of the body could just be a tube for the lead sleeve to fit in. Also, when I needed to iterate and change the whole design later on, I'd only have to remake one of the larger prints. I sketched out my first mechanism and rushed it to the printer. I wanted the design simple, no more than a half dozen parts, and all 3D printed if possible. It came down to the following: a collet, a spring, a collar to travel up and down the collet, and a backing for the spring and actuation. For me, the easiest way to make progress is to hold it in my hands, carry it in my pocket for the next few days, and have it on my desk at work to look at when I'm free. The first demo was a mess. Tolerancing was off, the spring was too weak, but by working it in my hands, it taught me that if I reworked this, that a solution was possible. One of my protos, I tried out making teeth, which gripped really well between the layers of 3D printed PLA. What was great about working with soft marking materials is that they'll actually tell you where your tolerancing is off. When one tooth is collecting a lot more material than the others, it's time to shave it down for a more even grip. I was making really good progress, and at this point, I started imagining what the final product would look like with me holding it. From there, I took a pair of calipers and my scaling Excel sheet and just pushed the pencil out segment by segment. Round pegs and construction adhesive would connect the layers, a decision I'd come to regret later on, and I was procrastinating the design, so I put myself on death ground. I immediately printed before the design was even complete, forcing me to push out each and every body segment as the previous one was actively printing. As the segments came out, they were collected on a PVC pipe that I'd used as a lead sleeve, and once they were all out, I started gluing and actually was able to use that sleeve as a datum to connect all the pieces together. Once the adhesive was dry, I filled the gaps with wood filler, and the entire structure was sanded down for painting. I'd never used wood filler or sanded or print before, so this was a lot more of a mess than I anticipated. What followed was layers of primer filler and spray paint, and a gloss that I'm pretty sure still hasn't dried in the weeks after it was applied. Standing as tall as I am, and somehow even skinnier, I'm so happy with how it came out. At first, I was printing with a higher density than necessary, and as I worked my way towards the cap, I kept pushing it lighter and lighter. Now that it's done, I ended up having a perfect tip-biased balance despite the fact that it's cracking under its own weight. The cap actually depresses and the clip is there, but the color matching and replication came out perfectly. This is a one-of-one model, and it's mine. And it works. It actually writes. I'm so happy with how terrible it is to use. I'm no longer legally allowed to use A0 size paper, but it still works on typical A4, or even a post-it note that's width is really less than 8 times the thickness of the lead itself. Sure, the TTP time could use some lowering, but it's a blast, and a great thing to lend to a friend in the class when they really need it most. Now, holding it in my hands, there's a lot to change in the design. First, I used dovetails to connect the body segments. The pegs I used only acted as 4-way locators, and by adding any more than the 2 in the same orientation, I was still not locking that 6th degree of movement, which was letting the body fall apart in translation. Next, the spring definitely needs to be out of metal. I'd say I knew this from the prototypes, but there was always hope that the next printed plastic spring elastic limit would just magically be higher than that of the last. And my biggest regret is not posting this sooner and with updates along the way. The energy that came my way after I posted the near complete progress online is what got me to actually make this video at all. In the process of making this, it came to my attention that there's no current official number for the world's largest mechanical pencil. This is a direct message to the officials at the Guinness World Records. At the end of this month, I'll be sending in my application with this exact video as reference. I haven't been able to find anything like it online, and I'm hoping it's the first of its kind. I can't wait to hear your response, and if it's not the largest, I'm ready to build bigger until it is. I look forward to hearing from you. Best regards, Bob.
So after I made the video, I realized that I never actually stood in front of the camera and held this thing so you get a sense of scale. When the cap is fully depressed, the entire length of it is 72 and 7/16 inches, and the entire weight of it's around 5 kilos. I have to pick it up with 2 hands right now because when you hold it with one, the sheer weight of it causes enough bending stress for it to crack, typically around here. Now, I've been thinking about this thing for so long, just holding it really just makes me smile. Making something is really hard, and documenting it and recording it and putting it into a viewable format's even harder, but I guess that's why I'm doing it. I want to spend this year making projects for myself, and this was number one. Okay, now bye.